Good morning, ladies and gentlemen. We are HD Flight Technologies. I'm Houston Brown, and this is Chandler Sambitz, and we're going to talk to you about our business idea today.
So, good morning, everyone, panel, audience. So, the big problem today is, do you have a clicker? Sir? Yes, sir. Thank you. So, the big problem today in the drone market is if you want to buy a drone that lasts over an hour for flight time, it's going to cost you at least $1,000. What we're looking to do at HD Flight Technologies is drop that cost and integrate by integrating solar panels and splice battery technology. Now, what that's going to do is it's going to increase the flight time by using the solar panel and the splice batteries. So, most excited about this is the local outreach. So, originally when we came up with this idea, we were thinking, all right, we could go, national-wide with this, just try and sell this as a broad idea. But we thought about the local market. So there's beach erosion, there's turtle nesting, and there's oyster beds, all within our local market. We've talked to the South Carolina Aquarium. They'd be very interested in buying approximately like 10 of these drones so they could do this, because you don't want to interrupt the natural habitat when you're looking into these. Also, I spoke with the engineering commander for the South Carolina State Guard. They are working, he is currently developing the code, the FAA regulations and code for the drones in the state of South Carolina. He mentioned to me that they are trying to find drones that will last a long enough time to do search and rescue missions, surveying land, looking at all the different types of flooding. We had the big flood this year. After hurricanes, looking at the, buildings, seeing how good a shape they're in. All those things they're interested in, and they're currently not funded by the actual federal government, which is different. So they would also be interested in drones like these.
So for our target market, drones are taking a huge hit. We're approaching almost 1 million users probably by the end of next year. We're right here at about 780,000 by the beginning of last year. And what we want to really hit on is these two markets. We have consumer and enterprise, and these compound annual growth rate of this is 30 and 50%. These are these huge markets that we're trying to hit. And then, as Chandler said before, we're trying to think about architecture for these missions that these drones can do, as well as small-scale deliveries, if we could incorporate it with inter-campus mail, making it really quickly and effective, as well as a historical and environmental protection like the beach erosion or doing maybe surveying for downtown Charleston. And so these are all the industries that drones can be operated with, and we're trying to hit as much of these as possible. What we're trying to do is make these drone kits that can hit each one of these markets. So for example, in agriculture, we could have a drone that implemented sensors to detect the quality of the air and just the basic environment. As well as security, if we could incorporate a drone with a camera that could do facial recognition software. So it's portable, it's quick, it's very cheap and effective. So the basic drone kit that we're going to try and start out with the local community is going to be priced at $350. We did some research, and with the drone right here that we have, it'll cost us about $170. So we'll get a profit of $180 per drone. And we're trying to do more research into this to increase the flight time for our drone as much as possible while keeping costs low. Because as Chandler said, these other competitors that we're facing against, they're upwards to multiple thousands of dollars.
So, HD Flight Technologies, we're here. We're trying to make drones that fly a lot longer. We're excited about it. We're a group of mechanical engineers from the Citadel. You can find us on Twitter at HD_flight_tech. We also have a website. There you can subscribe on that website and get the latest updates from our team. We're currently still developing the drone. Everything's just about done with it. All we got to do is find some connectors for the wires and hook everything together. We're really excited about it and would love for y'all's questions. So, thank you.
Okay, thank you. Okay, I like the idea. I like this, but tell me what where you see the business. Is it in the solar and splice battery technology, or is it in going a full step further and developing out with the solar and the technology? In other words, would you rather just develop the technology to extend the flight time, and then sell and license that to drone manufacturers everywhere, or do you want to have an exclusive drone that does all those things for all those industries?
Want me to hit on that?
Yeah.
Okay, so basically what our goal is to make the drone right now as a kit with the splice technology of the batteries and the solar panel. And what we're looking to do is sell that idea. This is just a commercial drone, and what we're going to do is show that we can make this kit to work with this commercial drone, and hopefully in the future find a company that's going to say, okay, we would like to use this kit on our drone, or say, you know, let's see who's going to buy it, and then we'll go into developing a drone from scratch that's just made specifically for the hybrid technology.
What's the time frame? Like you said, to go over an hour, you had to get a $1,000 drone.
Right.
How long does yours go? And I guess it depends on the sun and everything.
Right. So our drone is going to fly for an hour, but this commercial drone itself, we've done 6 tests on it, and without implementing the splice technology or the drone or the solar panel, it'll fly for about 15 minutes, which is the average flight time of a commercial drone. So we've also got here. So we've also this is our other battery we have, and the solar panel right here. We bought a bigger battery that came stock with the drone itself, and that increased our flight time by about 3 to 4 minutes. So we're currently also working on stripping down pieces of the drone to reduce weight and work on the solar panel and a mount for the solar panel. If you looked here on this slide, this is our prototype solar panel, and we're working on getting a slide solar panel so we can work more on weight distribution, because during the testing we noticed that with this heavier battery, the weight is unevenly distributed, so we needed to fix that by working with another mount.
So we're trying to incorporate as well, so it's like pros and cons. So the more things that we're trying to implement, the more weight that we're adding on the drone, which would decrease the flight time, but we're trying to find the best solutions to increase it.
To answer your question, the solar panel itself would ideally double the flight time of the drone. So if we can get the bigger battery with the solar panel to work exactly how we want it to, it should last an hour.
So would that work also with those $1,000 drones? If you use the technology on the more expensive drones, could you double their flight time too? Because if you're looking at search and rescue stuff, they may still want an amazing, expensive drone, but if you could double that.
That is definitely an option. Obviously, we're not working with a $1,000 drone. That wasn't within our budget to start with, but that is definitely something we could sell to another company.
Could you describe an application with architecture? You had it down there as a sector.
Yes, sir. For the architecture, so a big con with the drones is that the flight time, obviously. But if you have a lot of area to cover, these, as you increase altitude with the drone, that quality of architectural pieces will decrease. So being able to fly longer, you can get more data from all that, if that makes sense.
No, it doesn't make sense. What do you mean by architecture? I'm just not getting the word. To me, an architecture is a building, how it's built.
So we were thinking
I'm
about
not understanding the use case.
Yeah, so we're thinking about like surveying, especially for downtown, where you don't really want to go up because it's very historical buildings. So we want to do surveying to see if there need to be any repairs or anything like that.
Okay.
Yes,
The idea behind that is the drone can go where people can't. So
No, I got that. I just needed that explanation of what you meant by architecture.
Sorry about
Okay. And also, how are you able to create a drone for $350? And then when you say thousands of dollars for others, is that what the others, that's the price of the others? Or is that the cost of the others? And how do you know what that cost is? And why are you able to create something of equal quality that's $350 versus something that's thousands of dollars?
Yes, sir. So for those thousands of dollars, that's based on our research for the major markets such as Parrot, as well as DJI Phantom drones. So they have a lot of high quality parts, but with the low quality aspect, it's not necessarily low quality that's going to break easily, but we're able to easily replace it. Because if you crash a drone, especially one of those high-end drones, it's going to be very difficult to find replacement parts and be very expensive. And it's pretty much a guarantee that you'll eventually crash a drone, especially for the consumer market, which is the biggest market that's available. So being able to easily replace those parts is what we're trying to mainly hit on.
Okay. And what is it you would do if someone gave you a nice 5 or 6 figure investment right now? What's the priority?
Well, what we would really like to do is make drones with that. With either that, we could buy the same base model that we've had and replicate what we've done with this drone and sell it in the low country, But, you know, realistically, what we really want to do right now is talk to the aquarium, talk to the steak guard, talk to all these people who are actually interested in using this product for the low country, test it here, see what works with it. Because the idea behind this is, you know, the low country, it's humid, it's, you know, rainy sometimes, it's hot. You know, this is going to work completely different in Alaska or in a snowy environment, or somewhere out west. You know, it's a dry environment. So minor design changes we would have to make in order to sell that to that market. So we're just focusing on the low country right now and what we could do. And there might be more specific things, like the aquarium might say, okay, can you add this to your drone? You know, we need this to do whatever it is that they might need to do for the turtle nesting or whatever it may be. And we could say, okay, we can work with that and focus on that. So that's where we're going.
Okay.
Is there any other technology that you could use the solar powered and the splice battery on other than drones? Because that seems like the most exciting part of this development.
We haven't thought about it too much, but there definitely be some applications.
Any motor that runs through any electric circuit can use the solar panel. We actually tested this solar panel when we were doing the testing, because in order to figure out which solar panel would work best with our drone, we had to figure out what voltage and current was output by this. So we just hooked up a little motor that we have in our mechanical engineering department and put it out in the sun for a couple minutes and tested it, and it started running. We were able to get those readings. So it works with just about any motor.
Okay, thank you very much. HD Flight Technologies, ladies and gentlemen.